Hello everyone, I'm Mr. Brain and I welcome you to my channel. Today we will solve this very interesting exponential equation proposed at the Mathematics Olympiad. -2 raised to the power of x equals 2. The first step in solving the equation is to apply the natural logarithm to both sides of the equation. We then get log of -2 to the power of x equals log of 2. We now apply the properties of logarithms and multiply log of -2 by the exponent of the logarithm argument. We therefore observe that the equation does not admit real solutions because the argument of the logarithm cannot be negative. We must therefore look for the solutions in the context of complex numbers. We factorize -2 as the product of -1 times 2. We can now express -1 in two different ways. Given the square root of -1 is equal to I, the imaginary unit, we can replace -1 with the imaginary unit raised to the power of 2. The other way is to use Euler's identity. Given e to the power of I times pi plus 1 is equal to 0, we can replace -1 with the expression e raised to the power of I times pi. Let's proceed with the first method and substitute I squared in place of -1. We divide the left-hand side and the right-hand side of the equation by the natural logarithm of 2 times I squared. And simplifying, we get logarithm of 2 over logarithm of 2 times I squared. We will apply the product rule for logarithms, which says that the logarithm of a product is equal to a sum of logarithms. We apply the power property of logarithms multiplying the logarithm by the exponent of the argument. We have thus found the solution of the equation in the field of complex numbers. Let's proceed with the second method and substitute e to the power of I times pi in place of -1. We divide the left-hand side and the right-hand side of the equation by logarithm of 2 times e to the power of I times pi. And simplifying, we get logarithm of 2 over logarithm of 2 times e to the power of I times pi. We will apply again the product rule for logarithms, which says that the logarithm of a product is equal to a sum of logarithms. We apply the power property of logarithms multiplying the logarithm by the exponent of the argument. Since the logarithm where the argument is equal to the base is equal to 1, we have thus found another solution of the equation in the field of complex numbers. But are we sure that they are two different solutions? Looking carefully, we realize that the two solutions have the same numerator and the denominator differs only in an addend. We want to prove that the two solutions are the same complex number. To do this, we must prove that 2 times log of I is equal to I times pi. Let's write the imaginary unit I in exponential form. I is equal to e to the power of I times pi over 2. Applying the logarithm to both sides of the equation, we get log I equals log e to the power of I times pi over 2. We apply the properties of logarithms and multiply the exponent of the argument by the logarithm. Since the base a logarithm of a is equal to 1, we can write 1 in place of base a logarithm of e. Multiplying the right-hand side and left-hand side of the equation by 2, we get that 2 times log of I is equal to I times pi, that which was to be demonstrated. As the Latins said, quod erat demonstrandum. We have thus demonstrated that the two solutions represent the same complex number. That is, that the two solutions are two different ways of writing the same complex number. What a wonderful question. What a fantastic solution. If you liked the video, please don't forget to subscribe to the channel. See you in the next video, and don't forget, Mr. Brain solves problems.